So let's talk a little bit about the other trigonometric functions. Specifically, let's talk about secant and cosecant functions first. And I'm interested in the secant and cosecant functions because previously, when we've been talking about graphs, we've been talking about sine and cosine functions. Well, secant and cosecant are the reciprocals of the sine and cosine. Specifically, we have the identity that the cosecant of x is equal to 1 over the sine of x, and we have that the secant of x is equal to 1 over the cosine of x. And those are important facts right here as far as the domain of functions like secant of x and cosecant of x are concerned. And the reason why is that when we think about what happens with sine of x, at least in one cycle, we can see what's going to happen right here. Let's think about this. If sine of x, right, we have x and we have sine of x, we know that in one basic cycle of the function, when x is equal to 0, sine of x is equal to 0. When x is equal to pi over 2, sine of x is equal to 1. When x is equal to pi, sine of x is 0 again. And when x is at 3 pi over 2, sine of x is equal to negative 1. And then finally back at 2 pi, we see that sine of x is equal to 0. Well, think about what's going to happen now if we bring in the cosecant of x. Right? We will see immediately that cosecant of x is undefined at the points x equals 0, x equals pi, and x equals 2 pi. And if we were to keep going down the line, by the way, the cosecant of x would be 1 and negative 1 at these same places, right? So that's kind of important. But what we're seeing right here is that at 0, at pi, at 2 pi, and one would see at 3 pi, and at 4 pi and 5 pi, and so on, that cosecant of x is undefined. So if I wanted to define my domain of the cosecant of x, I might put it this way. The cosecant of x has a domain of all x such that x is not equal to some integer n times pi, right? Where n is an integer. So let me put that in the set of integers here. Maybe that'll help. N is an integer. So if we have that set, this is going to define our domain. Now, what the rest of the function looks like we'll demonstrate here shortly, but for a domain, at least it's easy to see that we're defined by where sine of x is equal to 0. And if that's the case, then let's think about where cosine is 0 for our cosine of x function, right? So let's think about it. Okay, cosine of x, we've got cosine of x within one cycle of cosine of x. Starting at 0, we get 1. At pi over 2, we're going to get 0. At pi, we're going to get negative 1. At 3 pi over 2, we would get 0. And then at 2 pi, we're going to get 1 again. And then the next 0 for cosine occurs at 5 pi over 2. Now, that's sort of interesting, 5 pi over 2. We see that if we look at our secant function, our secant function is undefined at pi over 2. That's supposed to be undefined here. At 3 pi over 2, and undefined at 5 pi over 2, and so on. And this is, I don't know, I guess maybe a good way of saying this is odd multiples of pi over 2, right? Because we've got 1 pi over 2, 3 pi over 2, 5 pi over 2. We would have 7 pi over 2, or negative 1 pi over 2, and negative 3 pi over 2, and so on. So how do we say odd multiples? Well, if n is an integer, if n is some integer, here's what we could say. If n is some integer, then we know that 2n is always an even integer. So to make it an odd integer, we're going to add or subtract 1. I always just add 1. I say 2n plus 1 is an odd integer. Right? So keeping that fact in mind, then, I would say that for secant of x, my domain is going to be the set of all x such that x is not equal to odd multiples, 2n plus 1, of pi over 2. Again, assuming that n is an integer right here. All right, so there's our domains right there. These are the two guys that we need to help us figure out what's going to happen with our secant and cosecant functions when we're asked to find the domains of them. All right. So here we are. Our domain, I guess I probably could have put this down here. Our domain of cosecant of x is going to be the set of all values x such that x is not a whole number integer value of pi. And the domain of secant of x is the set of all x such that x is not equal to odd multiples, 2n plus 1 multiples of pi over 2. In both cases, n is in the set of integers. Okay, how about the range? Now, the range is sort of odd, but let's think about it. For secant and cosecant, we're taking the reciprocals of sine and cosine. Now, with cosecant, right, since it's the reciprocal of sine, right, sine of x was a function that had y values that stayed between -1 and +1. Well, what's the implication for cosecant? Well, if we get a sine value like 1/2, which is between -1 and 1, that means we're going to get a cosecant value like 2. If we get a value of sine of x like square root of 3 over 2, we're going to get 2 root 3 over 3 for cosecant of x. In other words, since sine of x is contained between -1 and +1, cosecant of x will have a range that must be either less than -1, right? -1/2 has a reciprocal of -1 or -2, and or in the set of numbers from 1 to infinity. That is the set of all values outside of -1 to 1. And it works exactly the same way for secant, right? Since cosine is the kind of function that has a range between -1 and 1, just like sine does, then we're going to see that the secant of x is going to have a function range also outside of that interval from -1 to 1. So -infinity to -1 union with the set from 1 to infinity. All right, it's a little bit of a lengthy outline of the basic functions, their domains and ranges, but this is going to be important for us as we go forward. All right, more to come.